Okay, I hope everyone had a nice drink and some pizza and everyone did a lot of talking. It's good, but it's time to continue with the next talks. The next talk will be by Vangelis about, do I pronounce your name correctly?
Yeah.
About pointers versus values. It's a lightning talk. It will be a little bit less than 10 minutes. So applause for Vangelis.
So let's get right into it.
The microphone is not working. The microphone is off this time. So,
One, two, one, two.
raise your voice and you may still hold it if you want.
I don't know.
It's off.
And on again.
Oh, that's right. 1, 2, 1, 2.
Wait. Can you try again?
1, 2, 1, 2. No. Can you hear me at the back?
Yeah, it's fine.
Okay.
1, 2. No? Okay. Yeah, okay, let's, we don't need technology, right? So, it's a brief talk about pointers versus values, but actually debug. So I wanted to go more into detail what's happening behind the curtain. So using pointers or values as method arguments, actually this is how far code review can bring you. I'm saying that because when I made this comment in a pull request, I didn't expect this outcome. So I just said, oh, why did you change the pointers? Or why did you remove the pointers? And the answer was, let's benchmark it. So I was like, yeah, great, let's benchmark it. I'm right anyway, right? So I thought. But this is how we want to approach things a bit, like facts over arguments, and see actually what the code says. So the theory behind this, pointers, they allow for struct mutation. You avoid copying, you avoid the copying overhead, but they're not concurrently safe, and they might escape to the heap. Which means
There's a problem with the sound. There's music playing. Or is that from outside?
no, it's from inside.
And I also hear a hiss on the microphone. Maybe it's.
Oh, it's part of the presentation. It's my music.
That is off. I have no idea how this works.
Yeah, just if anybody doesn't hear something clearly, I'll try to speak louder and
Or go closer.
more clearly, but just, yeah, raise your hand or shout. So, escape to the heap. This means GC overhead or heap expansion cost in the case where you need to expand the heap. Values, you have immutability, it lives on the stack due to escape analysis in Go, but processing time overhead due to copying. So I did some simple implementations and benchmarks to see how actually these different approaches go.
Added drama.
So basically we have a method with a value argument, a method with a pointer argument, again for bigger objects, and also a method with an interface argument. So basically I've made all the objects adhere to this simple interface, and we have objects that have more and more properties. And the benchmarks basically, I just make a call of this method, just a simple code, and avoid the compiler optimization by putting this into a global property. So the results, pointers and interfaces seem constant in performance. This is a red and green line there. So on the x-axis we have the object sizes, right? So we went up to like 26 ints, 26 floats, and 26 strings. The value performance is degrading fast, exponentially, I would say, just by looking at this. And actually an interesting part is at the start of the graph that pointer and value performance is very much comparable for small objects. So that kind of makes sense because copying objects within a cache line is the roughly equivalent of copying a single pointer. So if you have small objects like under 64 bytes, it's probably the same. One thing to note is even if the object is less than 64 bytes, it might be spread across two cache lines, whereas the pointer always occupies only one. So it kind of makes sense the start of it. But I wanted to go deeper and see what happens even behind that. So I increased the iterations. I did for 100,000 and 100 million iterations. One thing to note is that actually the performance scales quite well. We can just see it by the digits. The leading digit is the same, they just increase it according to the number of iterations, which means benchmark was quite okay, and Go is also very consistent. And also an interesting part is the allocations. For pointer values are the same, and for interfaces there are much more. And going even deeper to look what happens even underneath, I looked at the assembly code. So without looking at the specific codes, we have pointers and values. A main difference is basically these two lines, where for the pointer you actually copy the stack pointer to a registry, whereas in the value you just use the stack pointer. So that's basically what we say lives on the stack or not on the stack. And here is also the PC data, which is basically a garbage collection metadata call. So it actually, we can see that there is some extra effort on the garbage collection. For interface versus values, it becomes even worse in terms of the assembly. So we can see two pointers for the interface, which is according to the theory and the iFace struct in the Go runtime. So pointer handling in interfaces is also by the book, so we can see also more lines regarding the handling of these pointers, and still this garbage collection overhead. And if we go into the implementation, into the usage of the methods, also the interface has much more overhead here, because it of course needs to find the implementation, the methods, check whatever is there. So basically interfaces also must do more work at runtime while their methods are being invoked. This seems to be the main differentiator in the performance. And next step, going even further, actually does it escape to the heap? What does it mean escaping to the heap? So I ran also the escape analysis. Pointers actually do not escape to the heap in this implementation. And I'm saying in this implementation we will go into a bit more detail later. So as you can see, the value does not escape, interface, it leaks to the heap, but the pointer also does not escape. And I also tried to do some garbage collection. Garbage collection of course has some uncertainty. So basically I trigger the DC, I check the stats, I print the stats, and this is basically the test function. It's one Go routine that creates the objects, one Go routine that signals the timeout, and just run the execution of the different methods. The results are also quite interesting. So invocation count and duration are consistent across the test. These are these two columns. It's basically just to make sure that I actually am doing some work and there's not something wrong with the tests. So the tests seem to be okay. Value receivers seem to degrade in performance faster. So the slope here is higher than this one for pointers. Although invocation of GC rise fast, so invocations of GC is x-axis and y-axis is the total post duration. Although they rise fast, the total post duration is under control. So we can see even if we do much more invocations, this is for interfaces there, we're actually not that high in the post time of our application. But we definitely need to look more closer into the garbage collection. So who won? Escape analysis, not all pointers escape to the heap. It depends on invocation details and object sizes. And also even value receivers can escape to the heap. Generally Go is very good in splitting the work across the heap and the stack. Assembly correlation, there are some expected differences, but in the end it all boils down to the CPU intrinsics. Design, interfaces of course provide more abstraction. There is no tight coupling, we can do dependency injection and stuff, but they harm performance. Although with large amount of data and longer running processes, we can see that the penalties amortize well enough by the Go runtime and the garbage collection. On the performance, pointers seem to behave optimally regarding performance. This is most probably due to modern CPU optimization, like prefetching of data. And on the garbage collection, actually the most interesting part so far for me, the garbage collector is really far too sophisticated to care in the end. I mean, it was really remarkable how the Go garbage collection performed in these benchmarks. Some things that you might ask, and I've tested and skipped mentioning. So compiler optimizations that don't seem to make a difference in these results. Compiler inlining, the same. And track garbage collection on the benchmarks. There were some inconclusive results because the benchmarks, you can't control how many invocations you have. So where next? We can simplify benchmark code by using arrays, actually. That's a great tip from Eric, and thanks for that. We can investigate with different method bodies. There will be a short appendix after that. Investigate breaking conditions like out of memory boundary, something I want to work on more. We can compare detailed escape analysis, so more M's on the GC flags, runs benchmarks on different CPUs to check actually the but it's not there. Yeah. Okay, there should be.
No, it's on
Display port. Okay. I was always almost finished, close on time, so I'll just say it out loud. So we can run benchmarks on different CPUs to see the prefetching and things like that, how, if it actually affects that much the performance. And we can investigate the same for method return arguments. And interesting part, very short, is also the appendix. So basically I did the implementation instead of using only the two parts of the structure, using all the methods, all the properties of the structure. And that was quite interesting in the benchmarks. So the performance of the pointer was still the best, but the value performance was very close. And the interface performance went really high up, so low. That means actually that what pointers do, so if you access only two properties of 100 properties of the object, then pointers is definitely the best choice. Whereas for values, you will copy the whole object. So if one thing is a conclusive result of this whole investigation, is that if you want to access many of your object's properties, seriously consider to use pointers, or if you want the design abstraction, interfaces.
Sorry for the technical difficulties.
Yeah, it was a lightning talk, so no questions, only after.
No, and a little bit time for questions. Anyone have any questions? No, so summarize your talk. I would say if a value is small, like maybe 8, 16 bytes, 32, you should pass by value if you can, because then it's concurrency safe. Otherwise, use pointers. That's the takeaway.
Yeah, actually, if you have like this common thing, if you have a coordinate struct where you have an x and a y, of
Small
course,
enough.
yeah,
Okay.
it's a value, no-brainer. But if you have, for example, also in your struct like a time and maybe a slice and maybe another struct, and you only want to access one property, then it's definitely a pointer. And then there's the whole gray area in between. That's why we're there, right? Otherwise, we wouldn't have anything to think about the whole day.
Yeah, we'll do a big talk about it. our next talk will be Victor. Victor is a senior developer at Sentia, based in Utrecht. And Victor is an advocate for clean code and automated tests, so he is going to do a talk about test-driven development.
Yeah.
Applause for Victor.
Thank you. All right, I'll try to speak loud as well. Hope you guys can hear me. So, I'm Victor, and I'm senior developer at Sint, as Eric already mentioned. I have a quick question for you guys. How many of you guys have heard about TDD before? Like, no. All right, that's a good crowd. How many of you think TDD is a good idea? All right, I would expect that. How many of you use TDD on the daily basis? Wow, that's really cool. Awesome. So, okay, so that was my question. So a little bit, try to meet a little bit the expectation for this talk. This talk, if you search about it on the web with other talks or articles or even read a book about it, you're gonna find that my talk is gonna be just like probably those talks, which are a sharing of someone's experience doing TDD and not doing TDD. And this talk is going to be about my experience. And one thing you should expect as well is that I'm not going to try to convince you by any technical terms or anything, because you ain't going to need it, TDD, but it is a good thing to have. If you're anything like me, you're always trying to improve your process to increase the quality and the productivity of your work. And yeah, so TDD for me, I do have the same appreciation for TDD, the same as I have for Go, because it allows me to be productive and also output a very quality on my work. Okay, so I know many of you already know TDD, but I'm gonna just cover some basics real quick, since the majority of you know what it is. So TDD stands for test-driven development. It is a development process, and it basically consists of you writing your test first before actually going into the code and the implementation. It is also known as red-green refactor cycle, and I'll explain a little bit about that on the next slide. And TDD is not a new thing. It's actually, there are records of other people talking about it in '68. So a little bit of how TDD works. The idea is that you start your work by designing, writing, and running a test for your implementation, and make sure that test fails with a clear error message, right? Once you get that nice test to fail, you step into the next stage of TDD, which is fixing the test, right? Creating the implementation and make your test pass. Not always, but most of the time, since you're focused on the second stage, on getting your test to pass, you don't need to think too much about how you did implementation, because you have the refactor stage where you're gonna clean up your code and make sure it's nice and neat to be deployed for production, for example. And then you repeat. So basically that's the red-green refactor cycle of TDD. Okay, so my talk is about the habit of TDD, and this is my entire experience with TDD. I associated a lot with a habit. And what I learned about habit is that it's a pre-programmed mode of your brain, right? So it's something that save you energy, some actions, a series of actions you perform without really using much energy. So it frees your mind to think about something else or work on some other activities. So habits are great for process. So you probably know where I'm getting with the idea of habit, because it fits perfect with the idea of TDD being a development process. So an example of a habit is like, imagine that you're backing out of a driveway, sorry. So your brain goes in this pre-programmed mode where you know what to do, right? If you do this for your first time, it's probably gonna have a lot of information like which gear should I put, where should I look, how much gas should I press, and things like that. And once you get used to it, it becomes an automated process. So your brain gets into this pre-programming mode that you're probably even thinking about something else while you're doing that. So it is obviously your brain is still semi-aware of all the components of the backing out, but you're not overwhelmed by all the information of the process. So it's something like this is like just like TDD. Yeah. So one other thing I learned about habits. So and the idea I pursued that information was to try and understand and change some old habits that I had. And they say a lot about the habit has three parts, or basically three stages. The first one is the cue, where it triggers you to react to something. So whatever habit that you have, it's probably going to have a cue where it triggers you to do something, or a sequence of things, which brings us to the routine, which is this sequence of actions that you probably have already pre-programmed. So you don't think too much about it, the cue triggers it, and you just do it. And for a habit to actually work, you need a reward, something that keeps you motivated of keep doing that habits, keep responding to those actions when the cue presents itself. So this is what my habit of TDD looks like on my daily basis, is that every time I have a task or a work to be performed and I have to code, this is usually my cue, and I go into this mode of red-green refactor as something that I don't think too much about it anymore. And obviously I get the reward once my work is done, and usually that reward comes from the reasons I do TDD. I chose to do TDD on my development process. And talking a little bit about the rewards, so those things are related to my experience, and most of the talks that you see or articles that you read, the author has their own things he finds valuable most, so they keep doing TDD because of those things, and those are mine. So the first one, which is a big one for me, is that I don't have to write tests after my work is done, right? So I don't know if you guys have to write tests as a definition of done for your task, but my team 3 years ago decided that this was way to go. And the thing with just writing tests afterwards is that you create the whole implementation and you sort of manually test it, and you sure that your implementation works. But then you have to write tests for it because it's part of the definition of done. Otherwise, your code reviewer will not approve your change. So that was a really big struggle for me, because most of the time I finished my implementation, but the code wasn't as testable as it should have been. So I have this bigger challenge of doing the test. So it feels like I was finished with my work, but I still have to do tests, so it didn't feel productive enough. And TDD, when I'm done with implementation, I'm done with my work, my tests are done. So this is a big reward for me whenever I'm doing TDD. So another reward for me is a clear implementation. And by that I mean, if you're doing tests correctly, every single line of your implementation is justified by your test case. So even if you get to a point where you look at your implementation and you see a line that you don't remember exactly what it does, you can comment that out and run the test. If you did your work correctly, your test case will highlight, and you know, oh, I added this line maybe because of that. Well, because of that case, test case that you're working on. So that's a big deal for me. So it's like a proof of the implementation that I did. Another one is the review before peer review. So before I submit my work for other coders to do the peer review, I can go easily through my test case and make sure I'm fulfilling all the requirements for the test. So that made me feel more productive because I don't have a back and forth because I forgot something during the review process. And then the next part is the get things done. So kind of the gamification type of thing. So I have this, for me at least, there's nothing more satisfying than a list of to do and I'll check how it's done. And that's the feeling I have every time I'm done with my work with TDD. I can see clearly everything that I did. And sometimes it even feels like playing a game, like I create this puzzle and I go ahead and solve that puzzle. And the last part, which is, it's not an often reward, but most of the time that I have to fix a bug, starting with the test, usually gives me, I can create a reproducible scenario that is actually code. It's not me clicking around or making curl commands request. It's an actual test case. It becomes a test case, which means that, again, it becomes a clear implementation, which for me feels like fixing a bug for good. I'm pretty sure that bug will never happen again because I created a test case that automatically, with the automated test, I can reproduce that error. So those are basically the rewards that I have for doing TDD over and over. But it wasn't like that in the beginning. So as I told you guys already, in the beginning I had to do tests afterwards, but I wanted to change that process. And changing an old habit, it's something that I didn't know much about it until I start researching more about it. And the funny thing is that the best way to change an old habit is changing your reaction to the queue by having a plan. So it's not just like, okay, I'm gonna receive a requirement and I'm gonna do TDD. That doesn't work like that because most often you'll be like, okay, where do I start? And that's what breaks the whole habit change cycle. So by having a plan, at the time, my plan was, okay, so I have this new task. Without thinking too much about it, I'm gonna write this boilerplate test code. And that for me turned me into this automated process already to get into the TDD cycle. And my boilerplate code looks like this one here, which is just a normal test function with a loop that has a table-driven data structure for my test case. And I already started out by having like the name of my test case. And then I have my very first test case right there on my boilerplate. So I named it empty because that's what it is. And inside this subtest, it's where I actually do the design of my unit. And I tested that design against all the test cases that I have created. So I kind of say that this part it's my canvas. It's how I want my picture to look like. The brush strokes or the colors are part of the implementation, and my test should reflect what my unit, my end result looks like. So one other thing that I found important for my boilerplate to have is not have any type of build fail. So if I run, for example, go test here, obviously it will pass because there's no test running whatsoever, but it doesn't block me to a process where I have to fix the boilerplate to get started. So let's do a little bit of an exercise with that simple task. Let's create a function that say hello, which I think it's most of the TDD tutorials to start with. So we have right now for this task two requirements. One, it's it returns hello world by default. And whenever this function receives an argument, it returns hello world plus the argument. Obviously, if you're working with that without using TDD, you can just go ahead and create a function and do these things. But this is a very simple task, so bear with me. In this case, so the first requirement, right? So the first requirement is to print hello world by default. So then I'm gonna update my boilerplate code by adding the expectations I have on this test. And I know now it's a string, so it's part of my requirement. And then I'm gonna update my first test case. Now I'm gonna put a name as default, and what I want to, what I'm expecting from it's the hello world string. And here's how I design my unit to be used. So it's different than thinking about creating tests for implementations, but it's more about creating sort of like the behavior, how I want my API, or if you're developing even a code within a company, this is where I usually design what my API should, how my API should be used and how it should behave. Yeah, so basically I call it like the package and then the method, and it will return a string, and I'm comparing the string with the what I expect on my test case. So if I run this, I'll get a build fail, and a build fail is not necessarily, even though some literature about TDD will tell you that a build fail is part of the second process. For me, I always try to not have build fail if I can avoid. So in this case, I knew when I was creating that method didn't exist. So nothing was preventing me from already creating this method. Because this doesn't feel like the definition of having a test with test failure with a clear message. So right now it's obvious for us that we know what it is, but it would be better if there was a better message. So, all right, so let's do the actual implementation to fulfill this test. And we're gonna fix the build problem by creating the function, and we're gonna return hello world because we're already there anyway. So now if I run the test will pass with the test case that I just created. All right, so we're done with that one. Let's move on to the second requirement. And the second requirement, it receives, the function should receive an argument, and it should return hello plus the argument. And now, all I have to do now, my test case changed a little bit. Now I have an argument to send them in. So I again update my test case data structure. And I don't really have to touch the first test case that I created, because by default, it means that the argument will be a 0 value. So I don't have to touch it, it's gonna be by default. Now my new test case, I call it with argument, and the argument's gonna be gopher, and expect hello gophers. So obviously I have to update now my design, and we already know if I do something like this and adding a new argument to a function that didn't expect, it's gonna be a build fail. And I don't want that, so I already know this. So I'm gonna just fix them up and put the function to receive the string as the argument. So just to avoid the build fail. So, and then if I would go and run go test, now I have a test fail. And this is what a clear message means. It's by, you created your test, so it's gonna say, wanted hello gopher and got hello world. And you can see clear here using the subtest that the test hello with argument fail. So this looks very clear to me what I have to do next. So then we just go ahead and create implementation for it so whenever I do not have a 0 value for the argument, print hello plus that. And if we run the test, it will pass. So this is a very simple example But it makes it gives you the idea of actually going through this process. And this is actually the end of my example here. But what I want to tell you guys is that I didn't want to add a refactor because it involves other things and extend the complication of the task itself. But it's part of the process as well. So once my test was done, if I could refactor anything on my code here, I would. But in this case, it's pretty simple. And so this talk is more about it's more about the TDD habit. So just by doing those things, you kind of get into this automated process of, hey, here's my test case, and now I have to update this thing. And it's so automatically, for me at least, that I'm already thinking of the next problem, or how I'm going to implement, or how I'm going to refactor that once I make this test pass. And it's not that I can advance and think, okay, I know how to do that, and then I just go and do it. It's getting to this mindless process that I kind of feel like I get benefits from TDD. So I go to this fail test, pass my test, and then make my code looks clean. So the takeaway from this talk is my idea behind it was to motivate you to give, if you have tried TDD before and fail, usually it's because you don't know how to start whenever you want to do it, or you don't know how to keep doing it. And maybe the reason is you need to find whatever is most value to you being the reason why you should do it. And if you haven't found yet, my recommendation is that you keep searching for it, because that's how I did, and that's my experience. So I added also in the presentation, which I believe will be shared later on, some reference. There is a great tutorial about if you're new to Go and you want to learn Go and TDD at the same time. There is this very nice tutorial. There's also a paper, because when thinking about reason, I kind of researched to see if even science could back us up. And but the truth is that there are so many papers and they all fail to create a conclusive result. In fact, you can find many papers with all the possible outcomes. But this paper is interesting because the researcher actually talks about other papers and basically his conclusion, his analysis on those papers. About habits, once I was researching about it, I found this course on Coursera called Learning How to Learn, which I recommend. Consider that we are all like long life learners. There's a lot of very cool tricks for you to learn more stuff. And I created a repository with this code in case you're interested. It's really basic, but it is available to you guys. And last, I listed a couple of interesting talks about TDD that I found to have changed my perspective on how I was doing it, and especially the Dave Shannon talk about unit is really interesting, because it's the sort of the essence of testing, but also the Ian Cooper talk is really good as well. Actually, Dave recommend watching the Ian. So it's, and the first one, the one from the Go for Singapore. I think so, Singapore. It's really nice because that guy's really funny. So that's pretty much it. That's my talk.
Thank you, Victor. Are there any questions? Yes. Try to shout hard.
How you dealing with dependencies? For example, you have task where you will introduce some new external dependency, database or something. How do you implement it in your TDD before the actual implementation? Because probably library could be different.
Yeah.
API could be different. Probably you will switch to another dependency.
So that's the thing. Usually dependencies is something that, so if we're searching for whatever package that we need to implement to our main source, we make sure it is tested at least when it's possible to. So you don't test twice. You don't test whatever code is out there. So whatever your actual code does, if you have a dependence that have a public situation, like, yeah, I actually, most of the time when I have a situation like that, if I can mock, I do mock, but if I can't mock, I probably try to decouple it from my application at some level. So that's basically how I do it.
And another thing is not a question, but more suggestion. There is a library called Go Tests,
Yeah.
which generates similar tests as you explained.
Yeah. So
Both
the
always.
whole idea for the boilerplate is actually, so I actually type it. So I don't even, because it gets me to the mood of while I'm typing, I'm actually already ahead thinking about the design, where I'm gonna put on the canvas part, you know? So it's more of, because I can obviously speed this up. I've seen some package that I can select whatever and it creates already all the functions. Like I have the functions, I can select the functions and create the test for me the way I want it. But the thing is, to get into that habit, creating this mindless process, it can help you. So you're not going to get productivity just by 1 minute that you type that small piece of code.
Any other questions? Then I have a question.
Yes.
So, would you advise to also test,
Yes.
use test driven development for internal functions or only for your
No.
external facing API?
You should. So there's a lot of other subjects I didn't cover in this talk because I only have 20 minutes. But unit, it's one of them, which is a unit should be what your API in your application programmable interface it's about. It's the behavior. So whatever, if you have unexported methods, you should not test that, not directly. So if you have unexported methods, you should test by the exported methods, which is the behavior of your API. So that's how you should do it.
Okay.
Well, that's how I do. Sorry, I don't know what you should do, but what I do.
Yes, well,
I guess it's a bit related, but is there types of code that TDD doesn't apply well to? I'm thinking about UI programming, for example.
Yeah,
Go
so
with the ideal
yeah,
choice, maybe.
that was another part of the subject that can be extended. So I found that TDD is very effective for unit tests, right? So if you watch the Ian Cooper talk about, he's going to talk about you have the test ice cream cone model where you have a lot of interface testing and then integration testing, and then you goes to a small unit test basically. But then he talks about you shouldn't be like that. It should be a pyramid where you have the unit test be the most covered ground of your application. So TDD for me works best for unit tests. But at some point when you do an integration, you're gonna need other components, right? Integration test, you're gonna, for example, you're testing an endpoint on API, web API, but probably you're gonna need a functional database. You either mock one or you need a container or whatever. So then it creates other dependencies that it's gonna make a lot harder and more expensive to create. So I highly recommend focus on unit tests. If your unit it's well tested, chances are you only have to test. For example, if you're creating a web API, you have to test if the format it's done the way it's designed, because the functionality of that endpoint it's already been tested by the unit. So that's pretty much it. So
Thank you. Yeah, I know for sure that at Pokey, where I work, we sometimes use test-driven development as well. I know usually I just write the code, I'm done with it, and then I'm like, oh fuck, I still need to write tests.
Yeah, exactly.
To test-driven development, you're done, and you're like, oh yeah, I already have the test. So
Exactly.
that's nice.
That's a big bonus for me.
Thank you for
Yeah.
your talk.
You're welcome.
We have some small presents for the speakers. They can come here to collect them. We have a nice mug for the full-length talks, and we have some covers 3D printed by Orne, one of the founder of this meetup. So if the speakers can come here collect it.
I'm here.
If you want to do a talk somewhere, if you want to do a talk somewhere in the next meetup, just come to me or go to the Slack channel Amsterdam and just say what you want to do there. Thank you again, Beat, for organizing, for sponsoring this place. It was almost flawless. It's a new office, stuff happens. But at 9 o'clock they're gonna kick us out. We are going to one of the 2 bars in the street down here, depending on how many people are coming. So if everyone's going down and stays there at the entrance, or if you want to go to the... Oh yeah, and there's security at the exit. If you want to exit, you have to show them a poster. So everyone bring a poster. Thank you.